In this video, I'm going to challenge myself to build a HTTP server, and I'm going to use codecrafters.io. So what happened is that Codecrafters approached me and sent me an invitation to let me check out their services that they offer. I heard that Codecrafters make advanced level programming challenges for software developers. And after some digging, I found that many developers are using their services, including staff level engineers at Google, GitHub, and whatnot. So I thought that since I have this opportunity, maybe I want to give it a try. So now I'm looking at this codecrafters.io and I haven't signed in yet. Let's take a look at this website together. So after you come to codecrafters.io, you are automatically directed to this catalog page where you can see all of the challenges. And there are like build your own Redis, build your own HTTP server, build your own shell, DNS server, BitTorrent, SQLite. Not too many. I'm surprised that they don't have too many, but they have different language tracks. So it seems to say that for the same challenge, you can use different languages. And let's say we're going to build this HTTP server. Why do I choose to build HTTP server? Because most of my courses are about ASP.NET Core, and whether it's Blazor or MVC or Razor pages, all of that under ASP.NET Core, most of that I would say, are about working with HTTP server. So it would be interesting to build a HTTP server so that I have a deeper knowledge of HTTP server. That will be very good. So let's click on this, and it says build your own HTTP server, and you can just click on the start building button, I would assume. And it also says this challenge is free until July 31st. So this is very cool. If you watched the video and you watched the video before this day, you can go in here and check it out. I'm pretty sure that there will be free challenges throughout the months, and it's not only just for this particular challenge and before this particular date. They could have promotions throughout. And there are different stages, looks like. And we can take on these stages. I believe you take on the stages one by one. And on the side, there are recent attempts. So let's log in and see what happens. So I log in with my GitHub account. And I'm looking at the same page. And nothing changed. So maybe before we do anything, let's click on this, see what happens. So previous steps incomplete. It tells me that I haven't completed the previous step. So if I go to the first one, it tells me, oh, well, I guess I just have to start building to see what happens. I'm going to click on this. Then I'm taken to a new page. And there is this introduction. Welcome to build your own HTTP server challenge. HTTP is the protocol that powers web. In this challenge, you will build a HTTP server that is capable of handling simple GET and POST requests, serving files, and handling multiple concurrent connections. Sounds interesting, right? We're handling GET and POST requests from scratch. Unlike using ASP.NET Core, you're handling it just in a function. Right, so if you know a little bit about MVC, the GET or POST or any type of request will be mapped to a function. So here, I believe you have to do it from scratch. So along the way, we'll learn about TCP connections, HTTP headers, HTTP verbs, handling multiple connections, and more. All right, so preferred language, we're going to use C#. That's my language, and that's what I teach in my courses, at least so far. So it asks you to select which language would you prefer to use, and we will create a Git repository with starter code for you to work on. So they will create a Git repository for me, and I'm going to select and see what happens. How would you describe your experience level with C#? I would select advanced. And then if you're already familiar with C#, can be a good way to further your mastery. If you get stuck, you can use code examples features to see code from other users. Okay, that's good to know. Next question. Practice cadence. How often do you intend to practice? Let's say every day. Accountability. Would you like us to email you occasional friendly? Well, I don't want to take the accountability thing. I'll pass. Continue. Now, it comes to the second stage where we're going to set up the repository. and it says in progress. So step 1, clone the repository. So I'm gonna just copy this code, and I'm gonna go to the taskbar, and I'm gonna click on this command prompt, and I'll paste it over here, and already started executing. So it created this folder for me, I believe. And if I go into it, it's right here. Okay, I want to see what's in it. So I'm gonna just copy this and go over here. So I can see the solution file, the project file that is created for me already. Okay, so let's continue here. Step 2, push an empty commit. Why do I have to push empty commit? It says when you run the about command, the listening for git push message below will change and the first stage will be activated. So maybe I can just run this directly. I'm gonna paste this command over here and I'm gonna hit enter. Okay, so now the site changed and it says git push received. It has this firework animation. Okay, the first stage is now activated. Let's continue. Now it goes to this step here. So how to pass the stage? Since this is the first stage, we have included some commented code to help you to get started. To pass the stage, simply uncomment the code and submit your changes. So that's a pretty simple task. Step 1, navigate to server.cs. Let's open the file. Okay, I have it over here. Let's open the solution. I'm going to use Microsoft Visual Studio. Alright, so I have my solution open on the right hand side, Visual Studio 2022. And if I open it up, I have the source folder and I have the server.cs they are referring to. So first step, navigate to source/server.cs and uncomment the code, submit changes. So we have some commented code. It says uncomment this block to pass the first stage. So I'm gonna just uncomment this block. Of course, this is a comment. I'm not going to uncomment this. So what does it do here? It uses the TCP listener. I don't remember. I think I have used TCP listener before, but I don't actually remember when. So anyways, it looks like it's starting to listen to this port, and IP address doesn't really matter. And then it wait for the client to connect. I truly don't remember what all of these means. I can make some assumptions. So it looks like they want you to investigate and learn it yourself. It doesn't actually teach you. Okay, so let's try to expand this and see. Mark as complete. Should I click on this? All right. And it says uncomment the following code, which I did. And I'm going to mark this as complete. Now submit. Run the following commands to submit your code. Do I have to run these commands, or I can just go to git changes here since I am connecting to the repository already? So here, so once you run the command above, yes, this is the message. I guess the message doesn't really matter. I'm just going to say stage 1 and save the file and push. The push, so commit and push. And now actually this test runner is running. So I guess it detects your push and then it starts some kind of testing. So, okay, test runner, test passed. And you can mark this as complete. I wonder what happens if I don't. Well, I guess we can do some experiment in the next stage. Let's mark this stage as complete. Okay, fireworks, view next stage. So you can see that at the beginning of a stage, the test failed. And there's some instructions here. Test fails, click here to view logs. So there are logs actually. To run the test again, make some changes to your code and run the test command. So this is, I guess, every time you come to a stage, it actually run the test automatically. And then it will tell you that something's wrong. So let's go back. Well, I need to click several times to go back. And once I'm back, I'm looking at this beginning page. Let's resume building. And now it takes me to here. Don't understand what is going on. So let me go here and resume. This is the respond with 200, which comes here. Okay, so let's continue. How to pass this stage? In this stage, you will implement your own solution. Unlike stage 1, your repository doesn't contain any commented codes to pass the stage. Okay, here we need to start coding then. And it tells you 98% of the users who attempt this stage will complete it. that gives you some pressure. Anyways, let's look at the instructions. So the URL task card below shows a description of what you need to implement a past stage. You also recommend taking a look at the code examples, which contain code examples from other users. Screencast tab, prefer more detailed video walkthrough. Mark this complete. Implement the solution. Head over to the IDE. You want a quick look at what functions to use and how to structure your code. We recommend looking at code example and tests. So what is the objective? Oh, your task is right here. Okay. So in this stage, your server will respond to a HTTP request with a 200 response. So this means that our code, this is a HTTP server. So the server.cs is basically representing a server object, and it will receive a request, and it will have to return a response back, and that response has to be HTTP 200. So HTTP 200 is the status of the response. It actually tells you what is the HTTP response, and it says a response is made up of 3 different parts. Each is separated by a character return. So in C# that would be \r, \n, and first part is status line, and then 0 or more headers, each ending with a character return, and then optional response body. So in this stage, your server's response will only contain a status line. Here's the response your server must send. So it actually tells you the response, and it gives you this, and also break it down into different lines here. So basically this is the HTTP version, and then the status code, and then the optional reason phrase, and each one of them has a space in between. So this is the status line, and it has to be all in one line with character returns here. So why there are 2 character returns? So this, I guess this separates status line from the headers, and then the second one separates the headers from the body. And because in our case we don't have any headers and we don't have any response, that's why these 2 are connected. I believe that's the case. So what should I do? Test. Okay, so there's nothing. It doesn't tell you what to do. It doesn't actually tell you what to do. So I guess if I don't know how to do it, I will have to do some kind of research. On the top, we have instructions. We have code examples, screencasts. What are code examples? But actually, there are code examples, so don't take a look at this right now, because we don't want to see other people's code before we start coding. And actually has a concept here related to this, and you can look at the network protocols. I was going through this early, so it has a 43%, and so let's say we take a new one. Well, this is in Rust. TCP is in Go. TCP and overview. Okay, let's take a look at this one. So let's see how it works. TCP is widely used network protocol. Is a reliable protocol that runs on top of unreliable protocol, which is IP, short for Internet Protocol. Let's dive deeper into it and understand how TCP works. Let's continue. And so it looks like it breaks everything into chunks, right? The bigger concept into chunks to help us to digest. We will start by looking at IP, the protocol that TCP builds on top of. Okay, continue. And now it asks you questions. Which of the following is true? TCP depends on IP. That's true. IP depends on TCP, and IP are the same. Okay, so this is correct. TCP depends on IP, which they just told you right here. So it looks like they're telling you some knowledge, and they come up with a question immediately to help you to retain that knowledge. Let's continue. So IP, the Internet Postal Service. When a program sends data over the network using IP, the data is broken up and sent as multiple packs. That's the term. I remember I learned this in university long time ago. That didn't change. So let's read. Each packet Each packet contains a header section, a data section. Okay, continue. The header contains a source and destination address, much like an envelope that you send through your local postal service. So you have header, which is the envelope, and then you have data, which is the information within. In this case, the following the metaphor, it's the letter within the envelope. So that's the header section and data section. Continue. The important similarity between IP and a postal service is that packets are not guaranteed to arrive at the destination. Although every effort is made to get it there, sometimes packets get lost in transit. Furthermore, if you send 5 packets at once, there's no guarantee that they will arrive at their destination at the same time or in the same order. So now it comes with the next question to help us to return the knowledge. When sending data using IP, which of the following is true? No packets will be lost. That's not true. All packets will be delivered in order. That's not true, according to what we just read, right? Packets may be lost and may be delivered out of order. That's correct. And it actually gives you more information here. Packets may be lost and may be delivered out of order because IP is a best effort protocol, meaning it does not guarantee packet delivery or order. Okay, I'm not going to go through all these things, but it's very nice to go through these things. You might have, just like myself, you might have learned at school, but by the time you'll challenge yourself, you might have already forgotten everything, and it's good to review it. Anyways, let's go back to. I'm gonna go to the root directory. I'm gonna continue this challenge, and which step I'm on here? Which step? Okay, respond. I'm automatically on the stage. I don't know, stage 4. Anyway, this is the current stage. And expand this, look at your task. So I don't know how to do this, but let's see. Let's look at the code and try to see what we can do. So this server start, and this returns nothing. It's a void method. This accept socket, it returns a socket. Believe I did this before, did it a long time ago, I don't remember, but at least I think I can get a socket and then I can use the socket to communicate. That's what I remember. It has a close method. Right now it asks me to return a response back. So maybe there is a write. No, it doesn't. I can send byte array. I can send, I think byte array would be really easy. So I'm going to use just the byte array. So in order to get a byte array, I remember that we can just convert string into byte array. So that would be simple. So what I would say is, I'm going to say response string equals, well, they provided this already. I'm just going to do a copy and paste. Okay, so I have this response string and I can convert it into bytes. So byte array, declaring it, and I'm going to say response bytes equals, I need to convert a string into bytes, and I can use encoding. Encoding dot, I don't know how to pronounce this, but ASCII, and I can get bytes from my string over there. So let's move this to the left a little bit. All right. Now, once I have this, I can probably just send it over. Response bytes. I'm just guessing. I'm making assumptions here. Response bytes. Okay, so I had a typo here. It's not response. Okay, so now the rest grid line is gone. I'm just making assumptions. I can just use the send method. But in order to make sure, so let's actually search for the socket thing here. So I'm just say TCP listener, because this is all from the TCP listener class. So I'm going to go to this TCP listener and see whether there are examples It listens for connections from TCP network clients. And the following code example creates a TCP listener. So it starts a server just like what we did, and then it accepts TCP client. So it didn't use accept socket, right? So let me search here to see whether I have socket. Okay, you can use either a TCP client or a socket to connect to TCP listener. So let's click on the socket here and see there are examples or not. The following example shows how the socket class can be used to send data. Okay, that's exactly what we need. So we need to get the socket, which we can get it right here, right? We get the socket, it's already connected by the time we accept the socket. That's my belief. And then once we have the bytes, okay, so they have a while loop here to receive data from the socket. But we don't need to do the receiving. We need to do the sending. So they use the encoding, and then they use, where's the socket? I don't see they use the socket to send data. That's weird. So maybe we can just search the send method here. We have begin send. Do we have to use begin send? Okay, there's so many. Let's scroll down. Send right here, and let's scroll all the way up. So socket.send synchronously sends data to the remote host specified in the connect and accept method. Okay, so it does send data. Let's see some examples. Example, the following code example specifies the data buffer and offset. Seems to be quite complicated. Do I have to do all of that? I guess I can just send data. Anyway, we can give it a test. All right, let's check in the data. Well, at least we need to build. All right, and let's go to the change, and let's say this is which state? This is what's it called? Respond with 200. Okay, let's say respond with 200 and commit all and push. So what is happening here? Okay, so test runner is running. Let's view instructions. Click here to view logs. Okay, so it's running test. This is actually real-time test. Time elapsed 4 seconds, I believe. And compilation succeeded. Run tests, logs from here. Received response with 200 status code. So it's passed, test passed. That's good. You know what? I want to see what happens if the test doesn't pass. Let's say I'm going to just, I'm going to send, instead of the correct response, I'm just going to send, let's say 200, okay. Oh, I cannot do it here. I'm going to change this to 200, okay. And let's see what happens now. So I'm just use 3 different lines here. I'm going to try it again. I don't know whether this would, okay, so this restarts the test. Okay, test didn't pass. Failed to read response, received 200, okay, and there's an error. Expected HTTP version, received 200, okay. Test failed. So it has to receive HTTP version, which we had it before, and it's right here. So it looks like they do have pretty good testing, and if you have any problems, they're gonna tell you. I wonder if I can do some other things. For example, I do some troubleshooting by spit out something onto the console, whether it's going to show up here or not. Let's try that. Let's say the response string is response string. And then I'm going to do the test again. So this time the response string has the HTTP version, and let's see what's going to happen here. Running the test. It takes some time to run the test, but it's not super slow. All right, so do I see my, okay, so this is my log. Response string is HTTP /1.1 and error says expected HTTP version /received HTTP version. Well, the message is not so clear, but at least it gave me some messages, and it also spit out the console.write write line. So if I have any problems, I can troubleshoot with this. Let's revert all the way what it should be, and let's check in again. I'm gonna say respond with 200, and this time it's gonna run the test again, and it's gonna take a while. So in the video, you're probably going to see that I'm gonna cut this waiting time, but you wait for, let's see, this is only 3 seconds, so not too bad. I believe it's longer than 3 seconds. And you can see what it's trying to do is it's trying to use this curl command to test. So what we can also do is to use the curl command to test the application ourselves. So let's try that. I'm going to run the application. Okay, this is running. I have my AVG antivirus going. Okay, pass the antivirus test. So this is the logs from the CodeCrafter program, and this is my window here. So what do? I use the curl command. Let's try. Let's clear this. CR. Oh, I forgot the clear command. Anyways, let's do a Control V, and let's see whether this works or not. It finished, but it doesn't show me anything. Well, it's exited with code 0, so I assume that's okay. Oh, I got some response from here. So I connected to here, and request completed sent off. So this is the response. Okay, good. This is the response, and the program ends. So I'm gonna just hit enter, and it finished. Okay, good. At least we can see that we can use this curl command to trigger our server ourselves. We don't have to use the test runner all the time. Let's go back. Going back doesn't work. So let's go to the challenge, but still doesn't work. So this navigation thing they need to work on changing, or maybe I don't know how to use it. Anyway, I can come over here and can see that I succeeded. Right, I succeeded this, and let's take a look at their code examples, what they do, other users. And you can see that they do more or less the same thing. This example used a simple line here, whereas I have 2 variables going. Anyway, so you can see how this works. And we can mark the stage as complete. And nice work, how did we do? I would say not too bad. I'm going to click on this, and let's go to the next stage. Next stage, your task. Now it gives your task first. Oh, I see some comments here. So they have some comments here. So the comments could be very helpful. My suggestion is you use a curl command to send HTTP request to test. All right. We can follow that instruction. I mean, a suggestion. We already tried to use curl command. So your task this time is a different task, which is you will extract the URL path from an HTTP request and respond with either 200 or 404 depending on the path. So there's some logic going on now. And then it shows us what is a HTTP request. So we're trying to extract the URL path from HTTP request. That's why we first need to learn the structure of a HTTP request. And HTTP request is made up of 3 different parts, each separated by a character return. So this is very similar to the structure of the HTTP response. Here we have a request line, and that's the same as response, right? Response would have a status line, and then headers and body. So this is the request line, and then headers, and then bodies. So the only difference is that the first part for HTTP request is a request line, and the response is a status line. Let's continue to look at this example. We have this separated by character returns. So this must be the first part, which is the request line. And then the second part has different headers. So, well, I guess there's the breakdown right here. let's take a look at the breakdown. So we have this as the request line, and it has the request method, which is the HTTP request verb, whether it's get or post or put or patch or different other methods. And then this is the target, the request target, which targeting a specific relative path starting from /. So this is the root, and that's relative to the host, which is in the header. And then the HTTP version and character return. So the headers tells us where, I guess the DNS, the domain name, right, which contains the host and the port, and then the user agent and the media types. So in this case, it accepts any media type. And then the request body, in this case, is empty. The request target, which is right here, specifies the URL path for this request. In this example, the URL path is /index.html. Note that each header ends in a character return. So character return, character return, character return, and then another character return. So this is a special character return that separates header from the body. But each one of these character returns are separators of the of each header. So that's a little bit special there. We have to pay attention when we actually work on extracting different parts of the HTTP request. And then here tells us how the test is run. The test means their tester. Once we submit the code, right, commit the code and push to the repository, the test runner is going to run, and it says the test runner will execute your program like this. So what is this, your server? Is it in our solution explorer? So we do have this your server.sh, and basically I guess it's going to just execute this line. And let's continue from here. The tester will then send a HTTP request to your server. First, the tester will send a GET request with a random string as the path, like this. So this is the HTTP request, and this is the random string. Your server must respond to this request with a 404 response. 404 means cannot find the location, right? Not found. So this response has to be, so our server have to respond with this particular response line back to the user agent. And then the tester will send just a single slash as the target. In this case, it's this command without anything at the end. So I guess without anything is applied, the target will be just a single slash. And in this case, your server must respond to it with a 200 response. So this response. And then it gives us some notes. Okay, so it says we can ignore the headers. What does it mean? So this is the headers. We don't need to worry about the headers. We need to worry about the request line. So this is mainly string operations. Right? Once we receive some data from the socket, we need to convert it. I believe it's going to be in bytes, and then we're going to convert it to string. And then we need to use the different structures, the structure specifications of the request to extract different parts. So in the notes, it's basically just saying that you can ignore parsing the headers, which is the second part. Right, the second part. We need to ignore the headers. We need to ignore the request body. Well, we don't have the body anyways. And then the request line. We just need to parse the request line. In this stage, the request target is written as URL path, but the request target actually has 4 possible formats. The URL path format is called the origin form, and it's the most commonly used format. The other formats are used for more niche scenarios like sending a request through a proxy. Okay, so we can read this, but I don't want to waste your time. When you use it, you can read this, and it's a whole learning process, I believe. For more information about HTTP requests, see MDN. Okay, so there's all kinds of documents we can look at. There's view code examples, view screencasts. We didn't go through this. So view screencasts. Build your own HTTP server from scratch, code crafters. So I guess there's 24 minutes. This is only 24 minutes. Well, I am doing this video way more than 24 minutes. But I'm wondering, what do they say here? So this is similar to my video, but I guess it's less detailed. I'm going to walk you through every single step. So let's go back again, and let's go ahead and work on this. So this stage is all about, well, I guess we just need to pay attention to two different things. First, we need to receive, which we haven't done. We only did sending part in the previous stage. In this stage, we need to first receive, and then we need to make sure we get the request line, and then we just need to extract the target out of it. So let's go ahead and work on that. First of all, I don't know how to receive. Let's take a look at socket.receive. Okay, so socket.receive. Okay, and I'm going to press on F1, a help documentation here. See whether I can find any examples. So basically, it just received data from a bound socket. And in our case, we already have a socket that is open and is bound. And it says the receive method reads data into a buffer parameter and returns the number of bytes successfully read. You can call the receive method from both connection-oriented and connectionless sockets. So I guess this corresponds to the TCP client. This corresponds to our socket. And I just want to see some examples. And there are different overloads. I want to use maybe just the receive byte. It takes me directly down here. Okay, so here is the example. But what if I have more than, what if this big buffer is not big enough? Anyway, so I guess in that case, we just need to do it in a loop. Okay, so like I said, the first step is to actually receive the request. So let's go ahead and work on that. For it to receive anything, we need to have a byte array defined. So this is the response bytes, and this is all about response. Let's do something right here. So here we got to receive, right? So let's say this is receiving, and let's define a byte array, bytes, and we're gonna use this new byte, the new keyword, just like this example here. So I'm gonna say new byte, yeah, 1024 is fine. And then we are going to use the socket to receive. So I'm gonna, receive into our buffer, which is the byte array here. And it's going to give me the number of bytes received. Bytes received equals this. I guess I have to do this in a loop. So I can do this while true, and then I put this in a loop. Now, once I have bytes array, I can convert it to a string. So I can use the same thing, encoding.ascii.getString, and then bytes. Oh, I think it's better to use the this variable that we defined, but we didn't spell it correctly. So bytes received, I'm going to use this right here, and the result will go into a variable defined outside, because this is in a while loop, right? So I'm going to define the string outside. I'm going to just say data, and then I'm going to assign data to the data variable here. Now we need to break out from the while loop if the bytes received is less than 0 or equal to 0. So if bytes received is less or equal to 0, then we're gonna break from it. And I guess that's it. Once we're done, we should have some data here. We can do some logging here, right to line. And I'm gonna say received data is data. Now we're not handling the response yet. We're just running this. And let's go back and take a look at the testing part. So basically it uses this. Okay, so we can run it and see how it goes. All right, we have this running here. Bring up a command prompt, another one at the bottom here. So this is the program, and this is our command prompt. What I'll do is I'm gonna copy this and I'm gonna paste it here. Now, if I do this, oh, there's nothing going on here. Well, the curl command did return back some information, but here there is nothing going on. We're supposed to receive data, and we're supposed to come over here and log. I don't know why it's not working. This logs from your program, so this is actually working, but here it is not working. So maybe we can troubleshoot. Let's stop this program here and let's run in debug mode. So I'm gonna set a breakpoint right here and run in debug mode. Okay, so it's not hitting my breakpoint. I believe we need to set a breakpoint at some other places. Let me do this, and let's set breakpoint right here. Okay, so breakpoint is being hit. I'm gonna go here and accept socket. So it looks like the accept socket is has kind of a blocking mechanism. It's waiting for the connection. And waiting for a connection, of course, is gonna wait because we don't have any we didn't send any request. So I'm gonna send the same request again. Send. Now it comes over here. Good. Let's try to read it. Okay, we actually have some information, right? 84 bytes. And let's convert this into string. Let's see what happens. Okay, so we did have the request. Look at that. So that's pretty good. And then bytes received and loop again. Oh, okay. It's hanging. It's hanging. So it's kind of like waiting for something. Receive. So it looks like the receive. I'm just making an assumption that the receive method is waiting for information, right? And because there's no information anymore, so it's waiting and waiting, and it doesn't stop waiting. So there has to be a way. So this break is not enough. Just using the bytes received is not enough. Let's go to the example here and see whether we can find some better examples. This example is the last one. Scroll up and see whether we can find some better examples. I want to search to see whether we can have a while loop. So we have a while loop here, but it uses a different signature. Maybe this is, oh yeah, I think we also had a problem here. I just used data equals. It cannot be just data equals. It has to be data equals the data. So I'm going to add a plus sign here to fix that problem. Stop debugging. And then maybe using a different signature will help. Let's try to use a different signature. Okay, so it tells me data may be null. So let's actually initialize that with empty string. And let's change this to use a different signature. Let's just say bytes dot length, and then socket flags. What is the socket flag? I guess none. And they're using 0 here. So I think 0 corresponds to none. The definition of socket flags. And you can see that 0 corresponds to none. We can try this and see how this works. Go ahead and run it again. And then run the here to here. Accept socket. It's being blocked. And use our command line to run this curl command again. All right, breakpoint is being hit. Let's go into here. Let's use this. The data at here, bytes received smaller than 0? No. Okay, can we run this? Okay, it's still being blocked. Doesn't actually work. I'm gonna do some research, and when I come back, I should have some solutions. I don't want to waste your time looking at how I resolve this issue. It's just a whole bunch of Google, I guess. Okay, so I was reading this same documentation, and here it has a paragraph. It says, if no data is available for reading, the receive method will block until data is available. So this explains what is happening in our program. And then it says, unless a timeout value was set by this, we don't have a timeout value, so we don't need to worry about this. So if you are in non-blocking mode and there's no data available in the protocol stack, receive method will complete immediately. Looks like we are in the blocking mode. So it says here you can use available property to determine if data is available for reading. When available is non-zero, retry the receive operation. So what we can do is to use the available method here. So I guess we can use available property here to say that if bytes received is smaller than or equal to 0, or if socket.available, socket.available, what is this? Is it a boolean? No, it is, so it says the number of bytes of data received from the network and available to be read. Okay, so if this is smaller, less or equal to 0, then we're gonna break out. This should work. Okay, let's try it again. All right, our command window is here. I'm just going to run the same curl command, hit enter. Oh, okay, that's wrong. It's not waiting here, so I gotta execute this. So now it's being blocked on the socket, right? And I need to run the command again. The previous one failed because we're not even listening. Here, I'm going to run the curl command. And now, look at this. We have the result printed out. So because it's gone through, I didn't set a breakpoint here. So this gone through and it worked. And when it comes here, it says receive data, right? So this is what we have here, receive data. And this is the request. This is the request. And as you can see, this is the request line, and these are the headers, and we don't have body. So that's really, really good. That means we got the data that we received. Well, there's no data in the body, but we got the request, right? So the next step in our stage is to do what? I forgot what I need to do now. So we need to respond with either 200 or 404. So it's basically saying that if the target is slash, which is the root, then it's going to have to return a HTTP 200 response. Otherwise, for any random path, it will return 404 not found. So this is a extracting mechanism here. So let's come to our code and let's say extracting. Let's just say extracting. So we're gonna extract the information from this data variable here. And this data variable contains the HTTP request. And basically we just need to do string operations, and the data is, it will just look like this, right? We have seen that in our code as well. So we need to be able to analyze the request target, and the request target is in the request line. So therefore we need to first of all get the request line. So how do we get the request line? So by looking at this raw information here, we can see the request line is basically this part, of course, excluding the character return. So we can use the host. I guess we can use the host word to identify the request line. So everything before host can be considered as the request line. So we can basically just take the data variable. We can say data.substring. I'm going to take from 0 until the data.index of, we're gonna find the host word, right? So I'm going to make sure that I got it correctly, and I'm going to declare a variable. I'm going to say request line equals this, and I'm going to console and output the request line. Again, use string interpolation, so request line is request line. Okay, looking at the request line, you can see that there are different parts: the HTTP method, the request target, HTTP version. Then they're all separated by a space. See, there's a space between each one of them. So we need to split the request line into different parts. And for that, I'm gonna declare a variable here, and I'm gonna say request line split. We're gonna split by, yeah, we can split by a empty character here. And now I can get any part that I want. So because of that, I think it's good if I just if I extract this into a function. So I'm gonna extract this into a function at the bottom here. You know what? Thinking of there could be different parts, and each one of the part actually belong to HTTP request. I want to actually create a class instead of just putting everything in the one file. And create a class that's object-oriented programming. So let's try to create a class. I'm going to add a new class here, and I'm going to call it HTTP. So this is for HTTP request. I'm just going to call it my HTTP request because ASP.NET Core has its own HTTP request. I don't want it to have the same name. So this is going to be used. I don't have to change it because this is only inside our, there's only one project. So internal should be fine, but I just have a habit of changing that to public. All right. So our method is going to get different part for the HTTP request. Therefore, I'm going to say maybe it's a public method. I don't know yet. So get request part. Maybe just call it that. And then we're gonna pass in. We only have, thinking that we only have these many parts, 3 different parts. So instead of calling get request part, I'm just return all of the parts. And the parameter here is just going to be the request request string, which we call it data in the server file here. Right? So I'm gonna paste what I have here, and I'm gonna change data to request string. So this is a string array that contains all of different parts. And we know that the first one is going to be the verb, right? The method. The second one is request target. The third one is the HTTP version. So what I would do is I'm going to just return a tuple. So I'm going to say return and request parts. The first one should be so I'm going to return a tuple with a parenthesis. So the first part is the HTTP method, and the second part is the target. The third part is the HTTP version. So the return type of this is going to be a tuple. I'm going to just say string, and I'm going to say method, and then string target, and the last one is version. So this is clear. And my HTTP request will have those 3 different parts. So I'm going to have those properties declared. So I'm going to say, let's say method and target and version. So because of this, we are going to have a factory method to create the request. So I'm thinking to create a factory method, which is going to be a static method. So I'm going to have a static method, and it will return us a my HTTP request, and I'm going to call it parse request. So once we parse a request, we're going to create a instance of the my HTTP request object. And how do I parse the request? I'm actually going to I'm thinking about moving the receive method inside, right? Because we are dealing with the request and we receive all the data from the request. So receiving should be part of the HTTP request. Believe that would make sense, right? So I want to move this part into my HTTP request class. And when I call this factory method to create the object, I'm going to call the receive method. So before I create the parse request, I'm going to create a receive method. So public, maybe in this case it won't be even public, but let's use public for now. We'll see clearly later. So because this is a static and this receive method need to be called inside the parse request, so the parse method will be static as well. So I'm going to say receive, and let's take a look at our code here. We're receiving data from the socket, right? So we're using the socket that is already open in the server.cs file. So therefore, I'm going to pass in the socket. Actually, let's say socket, and this socket comes from a different namespace here. Now, let me go to the server file and let's cut this. Actually cut this so that I can remember where is my receiving call. All right, moving this over here. We are going to return our data right here. Good. Now, let's continue with our parse request. First of all, we need to get our, of course here, this will have our socket object passed in from the server. And then we need to get the request string, which is from the receive method. Okay, so we're gonna say string question mark request string equals receive, and I'm gonna pass in socket. And if the request string is null, or we can say if the request string is null or white space, we're gonna return null. There's no request. Otherwise, I'm going to get different parts, right? I'm going to get different parts by calling this method. So therefore, this will have to be a static method as well. Okay, and I'm going to come over here and call it. So I'm going to say request parts equals get request parts, and passing in the request string. And here I need to create a HTTP request object. So I'm going to just say return new my HTTP request, and the method, which is the verb, is request parse dot method. The target is request parse dot target. That's correct. Let's see whether they generate the last one. Version is request parse dot version. That's great. Okay, so this factory method is created. We have this public. This is public. I would change it to private until we actually need it from other classes. Okay, so now we have our my HTTP request method here. I can go to server and I can actually let's move this inside the method for debugging purpose. Okay, right here. Paste it here. Good. Let's go back. We don't need this anymore. We can just use our my HTTP request object, and we can use this factory method here and passing the socket, and this will give us a HTTP request, right? So right over here, I'm just say request equals to this, and then I'm going to do some debugging. So if not debugging, logging for troubleshooting purpose. So if request is not now, I'm going to output them. So here I'm gonna say the method HTTP method is request.method, and then I'm gonna output the other three parts as well. So this is going to be the HTTP target is target, and then this is going to be the version, and change this to the version. So when the code runs here and it outputs the correct target, then we can use the target to determine whether we should output 404 not found or 200 okay. But before we do that, we need to make sure that our code runs correctly. So let's run the application, our program. All right. And then we are going to, I'm going to do this. This is curl command. I'm going to hit enter. Maybe let me make it and make this one bigger as well. Hit enter. Now it tells me, yeah, everything. It gives me everything. So our code is running correctly. So request line is this, and then we use the parse method, which is the vector method to extract all of the different parts in the request line. Right, where the target is this, the HTTP version is this, and then we can work on the task. Basically, tester will send a get request with, so only when we receive this this target, the root path, we are going to return to HTTP 200, right? 200 okay. So that we can do it in the server.cs file. So here we're gonna say if request is not now, we are going to see if the request.target is the root, then we're gonna say, well, we're gonna declare a response string here. Response string, which is right here already, but this time it can be different, right? So string, and then if it's this one, our response string will be 200 okay. Otherwise, our response string will be 404. Response string equals, let's copy this right here and paste it over here. And now I'm going to log this, output this as well. So console.writeLine, just to make sure our response string is correct. Response string. So it's not now here. Use unassigned variable. Maybe here we add another else statement, and we're gonna say if the request is now, we are going to also get a not found, and then we're sending that response. We're converting that response to byte array and send it over here. Okay, let's give it a try, and we're going to use this ABCDEFG or whatever, right? But this ABCDEFG is what the test runner is using. So I'm gonna hit enter, and it returns. So these are these three different outputs, and this is the response. This is the response. So yeah, this is the response, and that's correct. But since our program finishes, we have to run it again for the correct testing, which is the root, this testing, this test case, I mean. But before we do that, I'm going to use string interpolation to make this more meaningful. So I'm going to say response is the response string, and I'm going to run it again. Now I'm going to just use this address here, and I'm going to hit enter. Now the response is 200 okay, so it should pass the test now. Now let's go over here and let's push. So this is the extract URL, I think, stage, extract URL path. And I'm going to commit all and push. Let's take a look at the test runner. Okay, test runner is running, view instructions, click here. It's running tests. This time it really takes a while. Okay, did we pass? Okay, test passed and test passed. Very good. Compilation successful. Received data. Request line is this. Target is blueberry, and that's not found, so test passed. And then it tries again with the root path, and the response is 200. Received response with 200, status code, test passed, and everything success and test passed. All right. So what we have learned in this, we did a lot of coding actually. And I'm very happy that we extract this into a HTTP request, my HTTP request object here, class here. And what we learn is we're able to receive from a socket, which is socket that is bound. And then we learn to use the available to tell whether there's anything to receive. We use a loop to receive all of the data into a byte array, and all of the result is concatenated to a string variable here. And the rest is honestly just string operation, right? We just get the request line by using substring, and then we just split it into different parts, and we use a C# tuple to return the result, and then we use that over here in the factory method to create the my HTTP request object here. And then we use that object right here to test the target, right? Whether it's root or anything else. So that's all we learned in this stage. Of course, if you truly going through this, you will have to take a look at the articles that they posted, perhaps going through like what I did, going through the documentation, find and learn different informations. Especially here, we encountered a problem, right? When we receive, we were not able to receive because the receive method is being blocked. And that made me to read the documentation a little bit more carefully, and I found that I need to use the available property here. All right, that's everything we learned in this stage. We're gonna continue with next stage. Okay, let's go back. And going back actually works for whatever reason. They probably heard I complain about it. Let's go ahead and resume. Oh, I cannot. So go here and resume button. So although I can go back, I won't be able to continue. So I'm gonna just go to the catalog and go from here. I'm gonna mark this as complete and view next stage, expand this. So this stage says respond with body. So previously when we respond, we just send this empty body section with it. Where do we send the empty body? Response string. So we have this, and then body is always empty. So here it says we need to do something with the body. In this stage, you will implement the echo endpoint, which accepts a string and return it in the response body. Okay, so looks like the client is going to call this endpoint with a string appended, and our expected response will have to display that string over here. Now, because we're returning some response body, we need to add some specific headers. Previously, we didn't even add any headers. So here we have to have some headers. At least this is their requirement. Okay, the content type, which is text, and then the content length. So this has to correspond to the response body. That's what I assume here. Let's see. The two headers are required for the client to be able to parse the response body. Note that each header ends with a character return, and the entire header section also ends in a character return. Okay. The test runner's test case will send a GET request to this endpoint with some random strings at the end, for example, ABC. And your server must respond with 200 that contains the following parts. Okay, so yeah, my assumption is correct. Header set to the length of the given string. Response body set to the given string. Let's work on this. This should be a pretty easy thing. We just probably need to detect the target. So if it's root, we return this response string. If the request.target to lower, let's change it to lower, starts with echo slash. So should I say echo slash, or should I just say slash echo? I think I will do this because it doesn't make sense to call the echo endpoint without any string at the end. So I'm going to just say slash echo slash, and then here I'm going to add a question mark. And because I added the question mark, this could be null. So if it's null, then I'm just saying false. Okay. And under this condition, I'm going to provide a specific response. Let's copy this. response body. Here's the expected response. I'm just going to copy this, paste it here. So obviously this is not enough because the content length needs to be changed and the actual content needs to be changed. So again, we're going to use string interpolation here. And then here, it has to be a variable, and here it has to be a variable as well. So that all comes from the target. So here, we're going to say target variable equals to request.target. Do we need to change it to lower? I probably don't need to. And the target will start with slash and ECHO. So that means we just need to get the substring here. And we have how many letters here? 1, 2, 3, 4, 5, 6. All right, so come over here. We're gonna have another variable. I'm gonna call it content. And here I'm gonna say target substring and starting from number 6. Is it number 6 or number 7? So since this is 0 based, so it should be 6. I hope this is correct. Now our string, the response, should be easy to get. We can just say content.length, and then here we just put the content there. This should be our response. And the response is spit out here. A character return here to make it clear. \r/n, and let's give it a try. All right, program is running. Let's go over here. My antivirus is again triggered. All right, let's run the curl command. This time we're going to go to the echo endpoint, and I'm going to say hello, you, and then I'm going to hit enter and see what happens. So we have this response. Content type is correct. Content length is 8, and hello, you is in the body. I think this is correct. We got it right. Is it 8? 1, 2, 3, 4, 5, 6, 7, 8. That's correct. And let's just push this and see what the test runner says. Called response with body. Yeah, response with body. So I'm going to copy this. I think it doesn't really matter what's going to say in the description here. I'm just going to use the same title here. All right, coming back over here and see whether this test runner is running. And let's take a look what's going on in the tests. Test passed, everything is green. Yeah, so we did it. So it seems that this one is pretty simple. Once you get a hang of it, this is basically just the entire HTTP server is basically string operations. But anyways, it's still pretty cool to learn the mechanism and everything around it. There's some people having some suggestions, right? Yeah, so this guy is saying this. So you must reply 200 to this, you must reply 200 okay to this, and you must reply this to anything else. So as you can see in their testing, I can't show you anymore, but you will have to keep the previous logic there, right? So we have this root thing going on, and for everything else, it has to be not found, and for echo, it has to be this. So the code in the previous stages, you have to keep them there. Every test that it runs, it seems that it goes through all of the previous tests. That's why the test runner goes longer and longer. So let's go to the next stage. The next stage, this is read header. So this time we need to read the header. You can see your progress here. And all of this program seems to be dynamic, although it doesn't help you to know other people's progress. I don't know whether you can actually go there. Let's say you can go this person. Well, he or she is taking 2 challenges at the same time. What about this person? HTTP server, build your own shell. Yeah, he finished this HTTP server, and this one is build your own shell using Go. So they're different languages. Let's take a look at this. So in this stage, we'll implement /user agent endpoint. Another new endpoint, which reads the user agent request header and returns it in the response body. Here, you can see that every time we run this curl command, the curl command actually gives us something about the request. And one of the header is the user agent header. And because we're using the curl command, that's why it's curl. If you use a browser, it will show you probably what type of browser it is. Here, they're talking about what is a user agent header, right? So the user agent header describes the client's user agent. And if we want to know any information about user agent, we can click and follow this link. This takes us to mozilla.org. and we can know what it is the user agent. And in our case, let's skip this. Your / user agent endpoint must read user agent header and return it in your response body. Here's an example of the user agent request. The user agent is right here. We just need to read the user agent and get the value of that header. And then we return that response. And that response is very similar to what we have in the previous stage. It's just that here we need to return not the data, but the user agent. Now let's see what's the criteria of passing this stage. The tester will send a GET request, goes to the user agent endpoint with something like this, and then it's hitting this particular endpoint, or you can call it just URL. Your server must respond with a 200 response that contains the following parts: this and this and that. Okay, so let's work on that. So what we have done so far is that we are using the myHTTP request. And let's go to the definition of that. The myHTTP request has method, target, and version, but it doesn't actually have the headers. Let's go back over here to look at the request. Right, so what we did before was that we parsed this part and we move all of these parts into our properties, right? So this is the method, this is the target, this is the version, but then we didn't do anything about the headers. We ignored the headers. So in this stage, we'll have to parse the headers, right? So what we need to do, I guess, here is that once we have the request parts, we can't just return this. We have to also return the headers. And because of that, we'll have to define a header property here. So as you can see, the headers is a key value pairs, right? A list of key value pairs. Therefore, I'm going to use string, and then over here, we will just get all of the headers into the dictionary. So let's imagine we already have that method. And what are we going to do here? If we already have the get headers method, probably we'll just say headers equals to headers. Of course, we don't have it, but assume we have it. We're going to just call it here. And what are we going to pass in? We're going to pass in, again, the request string. The request string contains everything. Pass in the request string. Now, we know what we need to do, which is to implement this get headers method. So let's scroll all the way down here. And of course, it has to be static because we are using it in a static method. So here, we're going to say private static. It's going to return a dictionary just as what we define as the type of the property. So like that, and then get headers, string, request, string. Now, the first thing first is we need to get this part. So how do we do that? Previously, when we were parsing, we were using the host, assuming this is always here. Right? I'm not actually completely sure whether the host is always there, but assume the host is always in a header. Then if we make the same assumption, we can do the same thing, which is we are going to use a substring to get the entire part. Let's try to do that. So request string and substring. So substring has a start index here. And that start index, I'm going to just use the same thing here. I'm going to just use index of host. That's the first parameter, right? Because everything starts from this H here. So that's why I'm using index of host as the start. And then what is going to be the end of that? So look at this. I see something special about this, which is only the headers actually have 2 character returns. Right. This character return is for last header, and this character return is a separator between headers and body. So assuming there's always a header here, there has to be 2 character returns. So therefore, here, the second parameter, it's a length. So first of all, we will need to find 2 character returns. \r, \n, and \r, \n. But this is an index. This is not the length. The length will have to subtract the host index from that, and this will become the length. Okay, so now we have the header string. Let's say str headers. This is just in a string. It's not a dictionary yet. But what we're going to do here is we are going to split it into headers. So it must be a string array. I'm going to say headers equals str headers. And we're going to split that by, remember that the headers are separated by character returns as well. So \r\n, and we're going to get the headers. Here, I first of all want to just return a new dictionary. And the reason is that I want to test, I want to see what are the headers. So I'm going to say headers \r\n so that we can see clearly. And then I'm going to do a for each loop var header in headers. And again, string interpolation. The two parts are not separated yet. So I'll just say header. Okay, so I want to test this. And this is already being called here. So we should have everything displayed. So let's run the application. I want to make sure we're getting the headers correctly. So here, are we responding to the user agent endpoint yet? Not yet. But we're still using parse request, which is going to call, so we're going to have some logs anyways. And it doesn't really matter which endpoint we're hitting. So we have this headers here. Host is this, user agent is this, accept. So we're actually spelling out all of the headers. So it looks like we are fine. Okay, let's continue. Okay, so we got all of the headers. Probably we don't need to output this. I'm going to comment it out. Now we have all of the headers here in a array. I am going to construct the dictionary. So I will still need the for each loop. For each var header in headers. And within this loop, I will need to get the key value pair separated, right? And it's separated by colon. Like I said, looks like this HTTP server thing is mostly string operation. So var key values equals header dot split. So we split this by colon, and then we just need to add it to the dictionary. So we need to define a dictionary. We have to define it outside. So dictionary string, and I'm gonna just call it dictionary headers. And we're going to initialize that. And here, once we get the key value pairs, we can just say headers.add. And the first one is the key, which is key values 0. And I'm going to just trim it. And the second one is the value. So this is the key, and this is the value, which is the first one. All right. So here, since we have the actual dictionary, we're going to return the actual dictionary. All right. The get headers. And it's called right here. Once this runs, the headers property, which is inside the request, is going to be populated. Correct value, hopefully. Now let's go to server.cs, and we have to work on getting the responding to the user agent endpoint. So we already responded to the echo endpoint. We just need to come over here and say else if, let's do copy paste. Starts with user agent, I guess. Then we are going to just do the same thing, but instead of this time getting the target, we're going to get the user agent. So I'm going to say user agent value equals request.headers. And the header has to be the user agent header. Green squiggly line means headers, it can be null. So if it's null, empty string here. Let me just to the left a little bit so that you can see more. So this is the user agent value, and what we need to do is we need to have the headers and the response body just like that. So I'm just going to say response string equals, and then of course string interpolation, and I'm gonna copy the response from here. Yeah, it's gonna be this. Copy this and paste it here, and the content length will have to be user agent value dot length. No, dot length here is going to be our user agent value. I kind of forget about how this endpoint is going to be triggered. Where is the test? Okay, so I'm going to provide the headers like this. The target is like this, and then the user agent value. Okay, that's correct. I think that's correct. Let's give it a try. Let's run it ourselves first. And this time it goes to the, let's copy this. Let's copy this curl command right over here. Use this anymore because we're using headers. So header, user agent, and enter. What do we get? Response, 200, okay, content type this, and looks correct. So let's check in. And what is this called? Read header. I'm gonna copy this, paste it over here, and I'm gonna do a push. And come back and watch the test runner. Running tests. Okay, it looks like everything passed. Build succeeded, 0 warnings, 0 errors, and let's see what is the first test. The first test is actually going to hit the user agent, right? And they got the correct value, so it's all passed. The second test is going to the echo. So you see it actually tests the last one and then the previous stage. And then the next is the previous stage and previous stage. And then this is the first one. All right, so we passed the stage and let's move on to the next one. Let's come back and mark this as complete and go to the next stage. So this one is concurrent connections. It looks like we need to have some kind of asynchronous programming going. So expand this. In this stage, you will add support for concurrent connections. And it doesn't give you much, but just tells you what is the test case. The tester will create multiple concurrent TCP connections to your server. The exact number of connections is determined at random. So after that, the tester will send a single GET request through each one of the connections. The server must respond to each request with the following response. That's it. There's not much request. So there's people suggesting how to test this. Looks like people having some hard time testing this locally. Well, don't worry about that. Let's start coding. But which endpoint is it trying to hit? It's just the root? Yeah, probably just the root. Because currently, if you hit the root, it would just return this. So for this part, we don't need to worry about. We don't need to worry about the response. Because the tester will just hit the root. But the only thing is that the tester will hit the root concurrently. And the exact number of connections is determined at random. So how should we handle this situation? I think I need to do some research about how this listener works. Because right now, this accept socket is going to block. You can see it says wait for client. So if we want to have concurrent connections, we cannot let it block. So let's do some research here. Let's search for TCP listener. Let's take a look at this documentation here. So this one, it's not concurrent. It just accepts TCP client. So this is the same or equivalent to accept socket, just different ways. And it says perform a blocking call to accept request. You can also use accept socket. So this would be blocking and this would be blocking as well. So how can we not let it block? Let's read this a little bit. So here's this word block here. Use the start method to begin listening for incoming request. Start will queue incoming connections until you either call stop or exceeded the maximum connections. So it looks like when we say start, the incoming connections will be killed, right? Will be killed, which means that all the connections will stay in a queue. So use either accept socket or accept TCP client to pull a connection from the incoming queue. Okay, so those requests will go into that incoming queue, and then we can use accept socket to pull one connection. I think it's like a first come, first serve, and these two methods will block. If you want to avoid blocking, you can use pending. Pending method refers to determine if connection requests are available or not. So I guess if it's not available, so we don't even call the accept socket method. So let's go into pending and take a look. Some examples, if we have any. Return true if connections are pending, otherwise false. and there could be some exceptions. So this example says if there's no connections, just output this. If there is connection, it's going to accept the TCP client. So I think what we need to do is we need to change this so that we only accept socket when the pending method returns true. And then we need to do this accept socket thing in a loop. Yeah, so let's try to do that. So don't call the accept socket right away. Try to use if server.pending. So if it's pending, only when it's pending do we call the accept socket. But how much code should we include in this if statement? It's pending, we are going to accept socket, and then we use the socket to receive information, and then we send through the socket. Okay. I think everything has to be inside. If everything should be inside the if statement, I want to actually create a new method. Yeah, I'm going to create a new method here. I'm going to just create a new method right here. I'm going to say process request. And what should be inside the process request? It's hard to figure out. Let's first of all move all of the codes inside, and then let's examine that again. I'm going to cut this and move this inside. And then this process request will be called here. However, we're going to call it in a loop. So while true, this while true has to be outside here. So it's going to be while true, and then we need to check whether there is a connection in the queue, and then we try to accept the socket. Accepting socket is inside the process request. The thing is that we need to make this call asynchronous. So the simplest way to do that is to use the task run. So I'm going to say task run and lambda expression. So this will be called asynchronously. And I think we should ignore this green squiggly line. It's just saying that you're not using a wait. I don't want to use a wait anyways. So that means it's going to run in a loop, and then if there is a connection in the incoming connection queue, this will be executed. But it will finish before it finishes. It will not wait until it finishes. It will check whether there's another incoming queue, and then it's trying to accept that. I think this should be fine. I just want to have maybe console write. Let's just start processing a request just for us to monitor it. And then I'm gonna put this at the end here. I guess I don't need to have anything here. Now I can see that in the code example here, they call a close method to close the TCP listener and TCP client instances. I wonder whether I need to call the socket close. Yeah, because there's multiple calls going on. I think in our previous case, the program just ends, so that automatically closes the socket. So I think at least I need to explicitly close the socket in here. Yeah, after sending the data, I need to close the socket. And also perhaps we need to use the try catch to handle some exceptions. And I remember there is so this type of try catch, I'm gonna use that. So this is even before the server starts. Okay, so let me do this, just copy and paste it here. So I'm gonna just follow the example that they provided, and then there has to be a variable declaration right here, and here I'm gonna remove this definition, and then I'm gonna move all of this inside the try catch. The problem is that the server can be null. Right? The server can be null, and if it's null, then we're not doing anything. Yeah, that should be fine here. All right. Now, now I know why they're having problems testing this, because how do we, set up concurrent connections? It will be hard for us to run it, just run the curl command. So what I want to do is, I think I'll just want to save it, and then I'm going to just commit the code. Let the test runner to test the code. So I'm gonna copy this title and paste it over here, and then I'm gonna just push. Now run test is being run. Let's go over here to observe the test running. Oh, it says all tests passed. Oh my god, I'm so surprised that I passed this the first try. Start processing a request. You can see that they generated so many concurrent connections, so many of them. Oh, maybe this is because, right, there is pending. Okay, so every time this line is written to the console, it's really because there is an incoming call or incoming request. So they did generate so many different requests. I don't know how many thousands they did. That's interesting. That's interesting. I want to see what the other people do. Oh, I can hit, there is a cross there. I can just close that. I didn't know that. I want to see their code examples. Show me the code. So they're also doing it in a loop, but they put this outside. Wouldn't that be a blocking? See, if you put this outside of this task.run, it will be blocking, right? Let's see what the other person say. Client connects the server. Instead of handling the client directly within the main loop, a new task is started, which takes lambda expression, calls the handle client. This change allows the server to handle multiple connections concurrently. I'm not too sure. Because this is a blocking call. Well, I think the reason why this passes is just because it handled the client so fast, right? So in our case, this method finishes pretty quickly, and that's why it's working. But it's not really, it's still blocking because you're blocking it outside. You're calling this method outside of task.run. Therefore, it's going to be blocked until like each request the next request will be processed only after the previous request is finished. That's my understanding of this. Let's see whether there's other examples. There's only one example. Oh, we can even expand this. Can I close? I want to refresh the page. Collapse this example. Okay, so there's the next example. This guy also calls the accept client outside. Let's see whether we have something that's similar to ours. They're also doing it outside. Let's find something at the bottom. And they're also doing this outside. I'm so surprised why they are doing it outside. So I don't know why they're doing it that way. But I do want to try to put a line here. I mean a console.write line. So console.write line, and I want to say time of accepting the socket, and then I'm going to say date time now, so I can see the exact time. Hopefully I can see the milliseconds there. So I'm gonna push this again just for testing purpose. Now go back to this instruction thing, go over here, click here to view the logs. All right, now you can see that we have this start processing one by one. It doesn't even show me the time of accepting socket. So which means it's actually running asynchronously, right? And then we have this time of accepting socket, and then another one, and the response coming, and then another one. So this looks correct to me. But if we move this outside, let's move this outside. So outside of the process request, and just put it here. This is what they do in the code examples. And now I have a problem with the socket. Okay, so if I pass in the socket, right, then expecting that it's not going to truly running it asynchronously or concurrently. So let's give it a try and see. All right, Test runner runs again. Okay, so now you can see that it runs completely different. The log is just so little, although everything still passes, right? Everything passed. I mean, the test passed. Build succeeded, compilation successful, running test for EG5, creating 2 parallel connections. There's only 2. And start processing a request, time of accepting that. Start processing. So you can see this is 1 by 1. This is not really concurrent, right? This is really 1 by 1. You accept it, you process it, accept another one, you process it. So I personally think that accept socket should be inside of this process request, which is being run inside this task.run as a lambda expression. So let's move the code back. I'm going to move the code. I'm just going to do the Control Z and revert it so that everything is being called inside. I think this is a proper way to do it. And I'm going to check in again. And this should be correct. Now look at this result. It has so many, and this looks correct to me. It should have many because we're running in a while loop. It should be able to accept a lot of concurrent connections. Anyway, I think this is the correct way. And the test runner also says it passed, so I'm going to mark the stage as complete. Okay, view next stage. And this is return the file. In this stage, you will implement the file endpoint, which returns a requested file to the client. I wonder whether it's just return the file name or what is it going to return. Maybe the file content in the response. Let's continue reading this. The tester will execute a program with a -- directory flag. The flag specifies the directory where the files are stored. Okay, so this is going to run the program with the directory argument, right? And then provide the directory. This tester will then send a GET request. Okay, so this is 2 steps. First, it will run the program with the argument. And then it will send a GET request to the file's endpoint on our server. The first request will ask for the file that exists in the files directory. Your server must respond with a 200 response that contains the following parts: content header set to stream, content length header set to the size of the file, and the response body set to the file contents. So we have this example, stream, content length is 14, and the actual content is in the response body. Okay. The second request, where is the first request? First request, echo. Okay, so it's basically write this hello world inside the temporary folder, like this full folder, I guess. And then it's going to run this curl command. So this is not trying to contact our server. This is just trying to create a file, I believe. And then this is going to call the endpoint, the file's endpoint. Now the second request will ask for a file that doesn't exist in the file directory. So this, and your server must respond with a 404 response, not font. That's that's understandable. Let's try to work on this on the right hand side in the Visual Studio. So we need to know that they are calling our program with a directory argument. And then we should be able to get this path, the file path. So this is a file path, the folder that stores the files. And then the curl command is going to hit the files endpoint with a full, or it doesn't really matter, it's like with a file name. And that file name should exist within the folder, which is the folder that is provided right here. So I want to use the file exists system.io method to check whether the file exists or not. That will happen, I think it will happen within the process request, and that will only happen if they're trying to hit the file's endpoint, right? When they hit the file's endpoint, then we try to get the path, right, the directory name. and then the file name. So let's go over here and add another else if statement. So what's going to be inside here? This request.target, let's actually copy or to do it this way, paste it over here. So if the target starts with files slash, then we are hitting the files endpoint. And first of all, we need to know the folder, right? The folder name, and that is in the argument. So to get the argument, we can use environment dot get command line arguments, right? Well, I'm not actually too sure about this, but let's make sure it's really the case. I'll just say argument, and let's just say this is going to be a array, I believe. So let's see. For each, or I'm going to output this, and then I'm going to build the solution unassigned. Oh, okay. Here I need to, well, I guess I can just provide a default value here, and this should solve the problem. I'll build it again. All right, so now let's try to run this program from folder, and then go to bin, debug, net 8, and then I'm just copy this and open up a command prompt. Now I'm gonna cd into this, and I'm going to call the codecrafter.exe with the directory command. Perhaps this. Is that what they use? Yeah. Now I'm gonna hit enter and see what happens. Do I have a right line here? Wrote it. Okay, so let's give it a try. Oh no, it's waiting for, yeah, it's waiting. Let's wait for the antivirus. I can add exception, but since I'm recording this almost all at once, I don't want to go through the pain of adding an exception. Okay, so we're running this with a direct argument, and logs from your program will appear here. Okay, let me make this bigger so that you can see better. Now what we need to do is to open up another prompt, command prompt, and we are going to hit the files endpoint. So I'm going to do it here. I'm also going to increase the font size. Okay, so this one is here. This one is right here. I'm going to hit enter and see what happens. Oh, we do have a lot of start processing or request thing. I don't understand why it has so many. Well, we already use pending. So pending only when it's pending, which means we have. Oh, okay. It might be because once this process request starts, before it finishes, it thinks it's still pending, which is pretty weird. I don't understand completely. Yeah, that's probably require us to do some more research. But here we received this. Request line is this. Arguments is spelled out. Oh, no. I have a problem here. I think this has to be a $sign. And this is not a RV, it should be ARG. All right, so let's give it a try again. So I am going to close this and then run it again. Oh, no, I cannot run it again like this. I shouldn't close that. Copy this again, bring up another command, and then paste it over here. I mean, cd into the directory first. And then we're gonna call this with directory temp. Now I'm gonna hit the endpoint with the scroll command, and the argument is DLL. Well, and then we do have this directory, which means that when I call it, I didn't spell Y here, so there's a typo. So, but this is correct, right? And then this one. So, which means our code here that is using the environment variable is able to get the argument that we wanted. So I'm going to continue the coding here. I'm going to say if the argument is not null, Right, it's a directory. If this, sorry, it's an array, string array. If it's not now, then I'm going to loop through that. And I cannot use for each because I need to access the directory, this argument, as well as this argument. They're considered different arguments. So I need to use for loop. So I'm going to say for, and then Visual Studio is smart enough to come up with the coding that I wanted. Okay. Within it, I will have to say argv, and if the argument is directory, then I need to access the next one. This is not safe. So if I say if the current argument is directory, -- directory, and then the file path would be i+1. But you never know whether there's a file path or not. Therefore, I think this is not safe. What I think can be done that is safer is to use this. If the previous one is -- directory, then the current one must be the file path, right? So this will be safer. So this is the file path, and we need to define a file path variable here. Let's say file path is string.empty, and then here the file path is going to be equal to the current argument, and then we're going to break out from here. Now then the file name will be the file path plus the target. Okay, so let's say if we do it this, just output, make sure it works. File path is the file path plus the target. Should be inside this request. Okay, let's give it a try. Build again, and then go over here, stop this current one, and run it again. So this time I need to make sure I spelled correctly, and I hit enter. Let me increase the font size. Okay, so it's waiting for the command, and the curl command is doing this. And let's look at this. Where is the file path? Why I don't see my file path? Oh, there's still arguments which I already deleted. So that means it's still running the previous version. That's pretty weird. Oh, that's because I have some problems in my code. Okay, I forgot the semicolon here. Okay, let's build again. Ctrl+Shift+B. And now it should be good. Let's run it again. Okay, waiting. Now let's trigger the curl command again. From here, let's move this to the right hand side. And I'm going to hit the files endpoint. Hit enter. Now, where is my... So this is correct. Interesting. Doesn't work. So it looks like it's not going inside here. /file/. Is that our target? /file/. Yeah, that's our target. So if it goes inside here, this file path should be output. Why it's not? Let's set a breakpoint in here and run it this way. Although there's no directory argument, but at least we can oh, okay, so this needs to be closed. I'm gonna close this and then run it again. Okay, let's run the curl command, and we're here. Is the files? Yeah, it goes into here. Then why this is not? Well, doesn't really matter. It should output file path, right? So let's say run to cursor. Oh, index was outside of bounds of array. What is the I now? Oh, okay, yeah, that's because the first one, it will fail because this is 0 and this is -1. So here we need to add another condition. So if I is greater than 0, then we can do this. Well, because the first one will always be its own command itself. I mean the command itself. That's why you see that something to DLL, right? Okay, I think that's the issue. Okay, I think we resolved the issue. We can just do a Ctrl+Shift+B to build the solution, and then let's come back and run this again with the directory argument. And now we're waiting for the curl command. Okay, where's the curl command window? Right here. Do it again. Okay, file path is spelled out. Okay, this plus this. So is it because, so we have 2 slashes here. We have 2 slashes there. What is the target? The target is /files/foo. Yeah, it has this target here. I mean, this file is, the slash is always here in the target. So perhaps we can just get a substring out of the target, right? Like this, substring, and then starting from first instead of just the entire string. So I'm gonna stop this, and then do a Control B. All right, I'm gonna run this again. Now trigger the curl command after we fixed it. Now we have a correct file path. That's the entire file path. Now we can continue coding this. So if the file does not exist, we can work on the second scenario, which is if the file doesn't exist. If file exists, file path? No, this is the entire file path. Maybe we can just have a variable. I think it will be better. File path equals, pick this one. We need to have a string interpolation, a local variable. File path is already declared. Oh, we already declared it here. I guess this is a file name. So if the file name exists, then we're gonna do something. Otherwise, we will return this. Response string will be 404 not found. Okay, that's the second test case. The first test case, let's go back and take a look. First test case, oh, that's the complicated scenario. We need to output the content type set to stream, content length set to the content, and the length of the content, and the body has the content. So we need to work on that. First of all, we need to, I guess, read all of the content from the file. We already have the file exist over here. Therefore, we can use read, what should we read text, I guess, read all text. Opens the text file, reads all the text in the file, and then closes the file. Okay, I think this is what we want. So file name, and then I'm gonna say content. So once we have the content, we should be able to just return this pretty easily. Let's copy this whole thing, and then come over here. We're gonna say the response string is just this one with a semicolon at the end. And we need to make sure the stream is hard-coded. The content length needs to be changed. Okay, so let's go back. String interpolation again. And here will be our content length. And this content length will be, I think, content.length. Content.length. Yeah, that should be good. And then here is the actual content. And that will be just the content. Content. Good. We have the response string, that's it. I think that finishes our both the test cases, right? So what we need to do is to actually test this. But where is the file? File is under this particular folder, and this is a root folder, right? Well, I don't want to go through the pain of creating the file. Let's actually just push this and see whether we can pass the test. Push. Okay. Test is running. Click here. As I mentioned, we probably need to do more research on this. Start processing request. Nevertheless, it's working. Is it working? Does it pass the test? 404 not found. Does it pass the test? Expected status code 200 got 2404. Okay, it didn't pass the test. So I guess it didn't pass the test. Let's close this and see what it says. Okay, test failed. It expected. Let's see the log again. Why it failed? Well, before we do the research, I want to put this actually inside. I mean, I put this outside. This I don't want to see so many start processing. So let's do what we did last time. So I'm gonna have a socket here, and then I'm gonna cut this out. Actually, both lines. We're gonna cut both lines out, and then we're gonna go up and go over here and have the socket variable passed into here. And this should help us to limit the number of lines in the log. Okay, let's commit this and try to run it again. Okay, this time we have shorter logs, so we're able to see it clearly. Start processing a request. Expected status code 200. So what is trying to send? target going over here. File path. Not too sure where it's wrong. Let's take a look at the code. I think this should be okay. And this looks okay too. Looping through this. If it's I is greater than 0, directory file path equals this. And that's correct too. And then file path is, oh no, target. Oh, I see. The files, you see this? It shouldn't be part of this because this is the path, and then this should be the file, which is this part. Shouldn't include the files, right? So our file path is temp data. So this is all of the folder. This is the folder, and then the files part should be removed. So let's count. 1, 2, 3, 4, 5, 6, 7. So it's 0, 1, 2, 3, 4, 5, 6. Probably 7. Yeah, because we need to remove that slash. So this is going to become 7. Yeah, this will be, and file path, I can just say, well, file name. Actually, file name. Yeah, it should be like this. Let's check in this code and see whether this fixed the problem or not. Okay, so looks like everything passed. Scroll up. This passed. Everything is green. Right? Everything is green. Okay, so I think we're good now. Again, some string operations for this as well, and some file manipulations. Well, not even manipulation. Just use exists and read all text. Okay, let's click on this cross and mark this as complete. We can go to the next stage. Not sure why this is spinning forever. Let me refresh the page. Looks like we have some issue. I have some issue loading the page. I will stop recording and then I'll continue when this problem is resolved. Let's try again to mark the stage as complete. Okay, this time it works. Let's go to the next stage. This is a read request body. In this stage, let's expand it. In this stage, you will add support for the post method. Okay, so now we're working with post method. So post method means that there's something to post. That means there's something in the body of the request. So the post request to this endpoint, again to the file endpoint, which accept text from the client, create a new file with that text. Okay, so it's straightforward. We take the content from the post request body, and we create a new file out of that. Request body. A request body is used to send data from the client to the server. Here's an example of a post request. Again, similar request line, similar headers, and then we have a request body. So this is very similar to the response body that we created when we return the file content like this. So let's look at the test cases. The tester will execute a program again with the directory argument like this, and then the tester will send a post request to this endpoint, and then we're gonna just do that. It's a very obvious thing. The server will return 201. So 201 is similar to 20, which is it means that everything is okay, but in this case, something is created. So other than okay, and something is created. So your server must also create a new file in the files directory with the following requirements. The file name must equal to the file name parameter in the endpoint, which is this. So now we have to remember to remove this files here. So this is the file name. Right, and the file must contain the contents of the request body. Okay, let's work on that. Because first of all, we want to read the request body. Now we need to work on the my HTTP request. So we have the method target version and header, but we're missing the body, right? We're missing the body. So let's see the example. So we're able to handle, parse until here. We just need to add the handling of the parsing of the body. So what do? We already have the receive method. We have the get request parts. get headers. Now we just need to have a get body, I believe. So the private, again, it's going to be static and get body. So what is going to be in this? It's going to be the request string, same as the other method. We scroll up, you can see the get headers uses the request string. Get request parts uses the request string. Here, we're also parsing the request string. And we can just use the substring, I believe, because you can see that special feature here. We have 2 character returns. This is only possible by the end of the headers, right? At the end of the headers. So we can just say request string and then substring, and then we can say request string the index of 2 character returns, just like this. And then we need to, so that will give us this, but we need to remove these 2 character returns. So we need to add 2 to it, I believe. And then let's trim it. Just make sure there's no spaces. So this substring will be the body. So I'm just going to return this. And now we need to define the body on the top right here. It's going to be property and string question mark and say body. And then here I'm going to say body equals get body and give it the request string. So now we have the body. We can go back to the server, and here previously, if we're targeting the files endpoint, we are returning this. But this is not exactly the same here, because here we're handling the request with the get method, whereas this time in this stage we're handling the request with post method. So this should be separate, right? I think this should be separate. So instead of having just one process request, I want to have another method for processing the get request and another one for processing the post one. So let's scroll down and let's extract the post method, and it will return us a response string. So the return type is this, and then we're going to say process get, and I'm going to pass in a HTTP request. So here, scroll up, and if your request is this, and we can just, I guess we can just cut this out, I believe, right? Cut this out, and this will be in the process get. And the response string has to be declared inside here. Say response string, and then at the end, I'm going to return the response string. Yep. And now I'm going to call this process get over here. But I will only call it if the request.method is get, right? And now the response string is process get, and then passing the request object. Break it. Now we're going to do the post and break it. Now the response string will be in a different method. We're going to call it process post. Again, passing the argument, the request object. So I'm going to create that. I'm going to just copy this part and go over here. All right. So let's work on this. Process post, not process get. Process post. So again, we're targeting the get, not the get, the files endpoint. So let me copy this, copy getting the file path here, getting the file name here. But this time the file doesn't exist, right? So we don't need to check whether the file exists or not. So let me just copy this part and let's paste it over here. But the problem is that we have this part repeated twice. One is in the process post, the other one is in the process get. So I think we need to extract this out. Right? So we can pass in the argument array. Right? So I'm going to cut this out and scroll all the way down and add another method. I'm going to call it string get file path. And the argument is just this. And this should be okay. We just need to declare another file path variable here locally. String dot empty, not string.format. And over here, I'm just return the file path. And then this should be called here, okay, file path argv. Same thing, I'm going to copy this line, scroll up to here, and the file path equals get file argv. So I have the file path. Now, what do I need to do? I need to get the file name, which we already got from here as a content type. Should be this. But should we hardcode it or not? Tester will then send a post request. Let's read this. This content length has a request body set to some random text. The server must return the file name. The server must also create a new file, which the file name must be this. Tester will then send a post request to the developer with the following parts. I think we can hardcode. Hardcode the content type, right? So we just need to worry about the content length. Which will be inside a header here. So let's declare that nt content length equals, well, hardcode. I think since they're providing content type, we need to get the content type, right? So let's get the content length first. It's going to be request.headers if it exists, right? And then this is the content, and this is a string, so I'm gonna parse that. So parse, and when we parse this, before we parse this, this could be null. So we are going to say if it's null, then we're gonna supply 0. Okay, so content, that's the content length. Now we need to get the content type. I think it makes sense to get the content type. So content equals, again, it's from request headers, and if it exists, then we're gonna get the content type. Otherwise, we're gonna just use an empty string. So we have the content type, we have the content length. We just need to get the body, right? Body equals request.body. Now we need to have the response string. We need to declare the response string, the top. Here, response string should be equal to just this. So it's easy, it's just hard-coded. But we need to create the file. So it's possible that the content type is not right and the content length is not right, right? But the content type is what we got from them, so it should be correct. So we don't need to verify the content type. We need to verify the content length. So if, let's say, if the content length, okay, if the content length is not equal to body.length, then and else. Okay, if this is the case, that means that our response string should be different. And what should it be? Probably it's just the 400 byte request, right? 400 byte request. So we can copy this and move it up over here and paste it. So this, instead of 404, it's going to be 400, and then here a bad request. Okay, we know this because I created my course for ASP.NET Core API, MVC. Okay, from those, you know the return status code, and I still remember. So response string 201, when we have the file, but another thing is that we need to create a file. So in order to create a file, let's see whether we have anything about write. So write alt text, and that's correct. And we do have the file name, which is, we got it right here, right? So I'm gonna say file name, and then we provide the body. Okay, I think at the end, so if this is not hitting the file's endpoint, then we need to have the 404 not found, because if the client is doing the post method, then the only endpoint is available is the file's endpoint. So therefore here we're returning 404 not found, and then we're going to return the response string. And now we can call this process post about here, process post, we already called. And this response string is returned and tested here and sent here. Okay, I think we're good. I think we are good, and I think we have everything. And let's run. Can we run it? Well, we can't run it because we don't have the files. And let's just check in and test it here. So copy, paste, and let's watch this. Okay, go to instructions, go here, watch their test running. Did we just pass everything? It's so fast. Okay, they're testing this. Content length 67, content type this, and this is the body. Request line is this, post method targeting this. Response is 201 created, receive response with 201 status code test passed. We passed it. That's great. And let's close this and mark the stage as complete. Let's actually watch what they say. Test locally using also, okay, they're still providing some method for testing locally. I just skipped the trouble. Let's mark stage as complete. So what will be the next one? Base stage is complete. Let me increase this. So we are here already. Next one is about the compression headers. So for this video purpose, I don't want to continue here, but for you, I would highly recommend go through the HTTP compression. It will be pretty interesting because here it's all about string manipulations and a little bit about files and a little bit about concurrent, right? We just use a text.run, nothing fancy. Here, you're going to learn about compression, which is going to be pretty interesting and something completely different. But in this video, we gone through code crafters, and it seems to be, I think I like it. It's basically, it feels like you got to do your research to learn everything. It doesn't actually give you the video that guide you step by step. It has that video thing, but it's only 20 minutes. It's not enough. If you watch my video, it's going to be hours, and I'm guiding you step by step. But during the process, you learned the TCP/IP protocols. You learn about the listeners, the socket, and how to read data from the socket. And then depending on the data, we break it down, right? So we know more about HTTP requests and the HTTP response. It's just a protocol that is targeting a string, and the string has to be in a particular format in order to follow the protocol. And because we follow the protocol, we know the information within the HTTP request, and we know how we return a valid HTTP response. So this is also what we learned in this exercise. So if you're interested in code crafters, I have a link below. If you register and pay for this, I do get a share of this. I heard that many employees in Google and GitHub or a lot of other companies are using this. So if you're interested, check it out. There's some free challenges you can try if you're lucky when you first register. And if you like it, give it a try following the link. And thank you very much for watching this long video. I hope you have learned a lot from it. Just like myself, I also need to go back and fix a few problems. Let me know what you think about this challenge, and let me know if you want me to create videos like this in the future. Thank you, and I will see you in my next video.